Today's daily code problem of the day is flip columns for maximum number of equal rows, number 1072. For this problem, you're given an n by n binary matrix called matrix. You can choose any number of columns in the matrix and flip every cell in that column. So we're going to change all the values of each cell from either a 0 to a 1 or 1 to a 0 in the entire column. We want to return the maximum number of rows that all have values equal after some number of flips. So our goal, return the maximum number of such equal rows. That's what we have to do. First, let's kind of unpack how we're going to approach this problem. We can think about it like, if we take this for example, we're going to have kind of a very basic 2D array. Ignore these lines. So it's going to be 0, 1, 1, 1. So after doing 0 flips, we're going to have one row with equal values, this row right here. So we're returning the maximum number of rows that have all values equal after some number of flips. We could probably eventually figure out a way to get all the rows equal, but as of now, if we flip this, we're going to have 1, 0, right? So this is going to be our only row that we have. If we look at example 2, after flipping values in the first column, both rows have equal values. So we could look at it here. So 0, 1, and 1, 0. So if we flip these guys, we're going to have a 1 here and a 0 here, which means we're going to have two matching columns. So that's what we're going to use to kind of return our answer. Our approach, how are we going to approach this problem? We're going to use a hash map. So in our hash map, we're going to use pattern representation. For each row, we're going to create a pattern string where a t value is going to represent cells that are the same as the first cell in the row, and a f value represents cells that are different. So kind of like a true and a false. Then we're going to count the pattern frequencies. So we're going to store the frequency of each unique pattern using a hash map. Then we'll find the most frequent pattern, and the maximum frequency tells us the maximum number of rows that can be made equal after column flips. So this kind of simplifies it into a simulation kind of problem where we see how many things we have to flip, how that affects everything else. We're going to simplify it into identifying a frequency pattern. It may sound a little complicated, but let's go ahead and walk through it. First thing we're going to do is create a map to store frequencies. So we're going to have a map. It's going to contain a string and an integer. And we could call this our freaky map. And it's going to be equal to a new hash map. Then we're going to simply have a for loop, which is going to build a string, or have a string builder, which we will then use to convert each row in our matrix to a frequency string. So we're going to have for each integer array, because that's how we're going to traverse the 2D array, called row. In our matrix, we are going to have a string builder. We could call it our pattern, and it's a new string builder. We're going to initialize it to just be an empty string. We will now convert each row to a pattern using another for loop. So for each integer column, set that to 0. As long as column does not go out of bounds, so as long as it doesn't go past row.length, our column can increment. So a T letter is going to represent if it matches the first element, a F letter is going to represent otherwise. So if our row of 0 is equal to our row of whatever column we're currently on, then our pattern can be updated to append our T character. So true, it matches the initial character. Otherwise, pattern will append an F. False, wrong, you know what I'm saying? I'm sorry. Anyways, we're then going to convert this pattern that we built in this for loop to a string and use that to update our frequency map. So string row pattern is going to be equal to a pattern.toString. Boom. We love our string builder. And then we are going to put that into our map. So we're going to have our freaky map. We're going to dot put our string. So it's going to be row pattern. And then we're going to either get or default our row pattern. So get or default. Sorry, this should be freaky map. Freak dot get or default our row pattern, and we're either going to initialize it to 0 or add 1 to whatever is currently there. So now that we have updated our freaky map, we're going to go through each row and add each of our freaky maps to our hash map. And after that, all we have to do is find the pattern with the maximum amount of frequency. So int max freak. We could even get freaky with it. So integer max freak is going to be equal to 0. So for each integer, freak in our pattern, our freaky map, dot values. So for each key, basically in our map, we're going to try to update our max freak to be equal to the math.max of math.max of freak and our max freak. So it's as simple as that. After that, we can simply return our max freak, and that's it. That's our entire code. So if we run this, pass our test cases, and if we submit it, passes all solutions. O of n times n time complexity. Might be able to get it lower, but yeah, that's it. Thank you for watching. Follow for more daily LeetCode solutions. Check out the link in my bio if you want to learn how to code today for free. And yeah, that's it. See you tomorrow.